Exercise 8.1, question number 7. Prove that the opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles at the center of the circle. So here in the figure we have a quadrilateral ABCD circumscribing a circle with center O, where the circle touches the sides at P, Q, R and S. Given a quadrilateral ABCD circumscribes a circle with center O such that it touches the sides AB, BC, CD and DA at P, Q, R and S respectively. That means the circle touches the side AB at P, BC at Q, CD at R, DA at S. Now to prove that opposite sides of the quadrilateral, that is here AB and CD are the pair of opposite sides and they subtend supplementary angles at the center. That means AOB plus COD together is 180 degree, or the other pair of opposite side, that is BC and AD, subtends angle AOD plus angle BOC together, which is 180 degree. That is to prove. To prove will be angle AOB plus angle COD equal to 180 degree, angle subtended by the first pair of opposite sides, or the other, that is angle AOD plus angle BOC equal to 180 degree. To do so, let us make a little construction by joining all these points where the circle touches the circle with the center. It means OP, OQ, OR and OS are joined. OP, OQ, OR and OS are joined. Now proof. First, taking these two triangles, let us try to make these two angles equal. That is angle AOP and angle AOS by taking the triangle AOP and AOS. In the triangles AOP and AOS, first AO equal to AO or OA equal to OA. Let's say common side. After that, PA and SA or AP equal to AS, because they are tangents to the same circle from the same external point. As we know that tangents from the external point, from an external point to the circle, are equal. So AP equal to AS. We'll just write tangents from A. Lastly, OP equal to OS, they are the radius of the same circle. OP equal to OS, so radii of the same circle. Therefore, by SSS congruency theorem, triangle AOP is congruent to triangle AOS, which now makes these two angles equal. It is angle AOP is equal to angle AOS. Similarly, we can say that these two angles will also be equal. That is angle BOP equal to BOQ. Let's call this equation 1. Similarly, angle BOP will be equal to angle BOQ. Let's call it equation 2. Same thing here. COR will be equal to COQ. Angle COR will be equal to angle COQ. Let's call it equation 3. And DOR will be equal to DOS. Angle DOR will be equal to angle DOS. Let's call it equation 4. Adding equation 1, 2, 3 and 4, we get, let's see what we've got. Adding all the left hand side, angle AOP plus angle BOP plus angle COR plus angle DOR is equal to angle AOS plus angle BOQ plus angle COQ plus angle DOS. Now AOP plus BOP, AOP and BOP gives AOB. Angle AOB, COR plus DOR gives angle COD. And AOS, let's add with DOS, that will give AOS and DOS AOD. Angle AOD, BOQ and COQ, BOQ, COQ gives angle BOC. Let me call this equation 5. So AOB, COD together is equal to AOD plus BOC. But when we add all these angles together, that is angle AOB plus angle COD plus angle AOD plus angle BOC, it gives 360 degree. The reason is AOB plus COD plus BOC plus AOD all together makes a complete angle that makes 360 degree. But this AOB plus COD is equal to AOD plus BOC, so we can write twice of angle AOB plus angle COD, which is 360 degree. And now angle AOB plus angle COD is equal to 360 by 2. So angle AOB plus angle COD is equal to 180 degree. I've proved the first part. And we can also say that angle AOD plus angle BOC equal to 180 degree. We have it in equation 5 from equation 5. That means angles subtended at the center by opposite sides in a quadrilateral are supplementary, that is 180 degree.